Hello, we're doing checkpoint 4.41 from section 4.8, and they want us to take the limit as x approaches 0 from the positive side of 1 over x minus 1 over sine x. If we just put in the value of 0 in for x here, we're going to get 1 over 0, which is infinity, minus sine of 0 is 0, so that's going to be infinity as well. So infinity over infinity is not going to equal 0 because the speed of how fast this goes to infinity might be different from the speed of how fast the second term goes off to infinity. So it might not reach infinity at the same time so that you get 0. One might be faster, so it might go off to infinity or maybe even negative infinity, or it might actually be a finite number if they're going to infinity at about the same rate. Same rate but slightly different. Well, we'll have to see how that goes. Our first step in dealing with indeterminate forms like this would be to first make it into a fraction. And since these are fractions already, we just find common denominators and write it as one fraction. And not applying L'Hopital's rule here yet. We're going to take the limit as x approaches 0 from the positive side. And now we're going to apply it. So I'll multiply the first one by sine x over sine x. And this will give us a denominator of x sine x. And 1 times sine x is sine x. And then this is just a common denominator. So the second term, I'll multiply this by an x over x, so that my denominator is x sine x, and I'll have an x on the numerator. And then that's it. Okay. If you can simplify it some more. It doesn't look like we can simplify it at this point, so we'll take the limit as x approaches 0. I have 0 minus 0. 0 minus 0, by the way, is not indeterminate. It is going to be 0. And then here we have 0 times 0, which is equal to 0. So now it's an indeterminate form. And we'll plan to use L'Hopital's rule in our next step. So equals conditional to L'Hopital's rule and the limit finally existing. X approaches 0 from the positive side. The derivative of sine is cosine. And we have 1. And then this is going to require a product rule. Derivative of the first times the second plus the first times the derivative of the second. And let's see where this goes. And we take the limit as x approaches 0. Cosine of 0 is 1. 1 minus 1 is 0. Sine of 0 is 0, and x is equal to 0 times 1 is going to be 0. So this is still indeterminate, and it looks like we have to apply L'Hopital's rule again. So applying L'Hopital's rule again, I'm going to take the limit as x approaches 0 from the positive side. Derivative of cosine is negative sine, and the derivative of 1 is 0. The derivative of sine is cosine, and here is going to be another product rule. So it's the derivative of x times the second, cosine, and plus the first times the derivative of cosine is negative sine x, and that's it. And now let's try to take the limit again. Sine of 0 is going to be 0. And this is cosine. This is going to be 1 and 0. So this is going to be 2 in the denominator. And now it's equal to 0. So this is equal to 0. Again, infinity minus infinity doesn't always equal to 0 because this might have been an actual value that we would get. But in this case, we end up getting 0. And it is, and we had to use L'Hopital's rule twice, and by my notation here, you can see exactly the steps when we took L'Hopital's rule, and then once we did that, then we're able to find our solution. Okay, I hope that helps.